Okay, friends. So, I think very quickly, just we'll go through the vapor absorption refrigeration system. I think this we have discussed the working principle and all that. So we'll move on to the different properties of the refrigerants we use, and also what are the desirable properties which can be considered before we use it as a refrigerants in the refrigeration system. That also we'll discuss, and very briefly, very quickly, we'll just go through air conditioning system and applications of it, and then we'll close this module today. Mm, we know that there are different properties which is going to be considered before we use as a refrigerant. So normally freon or ammonia, which we use it as a refrigerants in the household applications, but each which is going to have its unique properties. Maybe so what are the few properties which are going to be considered that we discussed today? The temperature, the latent heat, of evaporation is going to be considered as one of a major property for any refrigerants which you use it. So the latent heat of evaporation, in the sense it's a boiling point, I could say. So boiling point would be different for each substance. For example, if you take acetone at atmospheric temperature itself, it starts evaporating. If you simply just open it, it starts evaporating it even at ambient condition. But whereas the water, if you take, even though the chemical compositions of the water is going to be remain same irrespective of its change of phase. It's really a fantastic property which can be used, but the major problem with the water is going to be the boiling point, because the boiling point of water is going to be 100 degrees Celsius. So normally any substance or any refrigerant, it's really supposed to be a moderate boiling point, I would say. For example, it should be at 40 degree or 50 degree, it should be starts boiling, because uh, in the refrigeration system we may not get the 100 degrees Celsius to boil it, because the refrigeration system which works on by change of phase from liquid to vapor and vapor to liquid. So here in the refrigeration system, sometimes we may not get that temperature to evaporate. So that is the reason we use it any refrigerant which is supposed to be having a lower boiling temperature. So water we may not going to be used. So that is the reason, though it have a very good properties. So with respect to temperature, it should be evaporating temperature to be above atmospheric. Of course, it should not be negative, but should be less than water. I mean to say, it is in the range of 40 to 60 degree or 70 degree. So the pressure at the corresponding condensing temperature should not be excessive, so that because in the condensation is nothing but it is a heat exchanger. So it exchanges the heat from one substance to other substance, or one substance to surrounding substance. That is, normally we use air or water as the heat exchanger. So here the condensing temperature should also be not exceeded. So similarly, low compression ratio is desirable, and discharge temperature of the compressor should not be excessive, because it creates a breakdown or dilution of the lubricating decomposition of the refrigerant, and sometimes it also leads to forms of some sludge or acids. So all of this can lead to compressor damage. So that is the reason. So the temperature is going to be playing a very vital role while selecting any refrigerant for particular application. And also it depends on a specific application. For example, industry, it may be different, or household or smaller size is going to be different. So it depends on uh, various factors. So high latent heat of vaporization and low specific volume is also very important, and viscosities, it should be low viscous, because otherwise what will happen if it's a high viscous, the entire refrigerant is going to be flowing in a smaller tube, from evaporator to condenser and condenser to evaporator. So it's a very small tube. Maybe it is in the range of maybe below 10 diameter. So if it is a high viscous fluid, it is normally it will stick to the tubes. So it should be very low viscous. Should be very low viscous. Should be the refrigerant. So otherwise it will stick to the surface, and block the channel. So that is also very one of the important parameter. So that is the reason we also use low specific volume of the refrigerant at the entry of the compressor as desirable, because the channels provided is going to be very low. So in order to low compression work, of course, the COP is completely, the coefficient of performance is entirely dependent on the work which is going to be supplied for the compressor. So compressor is the heart of the engine, the heart of the refrigeration system. So it consumes, if it is a, it consumes low power, then of course the COP automatically enhances. So these are the few properties which we considered as considered. And of course there are some chemical properties also very very important while selecting any refrigerant. That could be, it should be toxic free, it should be flammability, its chemical stability, and also it should be non-corrosive. So all that, these are the chemical properties also need to be considered before we use it for any refrigerant. So of course we will any as I was mentioning in the beginning, that each property will going to have its unique properties. Maybe some going to be very good at chemical properties, some maybe good at thermal properties, some maybe good in terms of viscosity and all that. So probably the completely entirely good, satisfying all the condition we may not be get. But of course within this complexity which is being involved, within that we consider these are the desirable properties. Based on that, the refrigerant can be selected. So as I was mentioning, that high latent heat of vaporization, that is a maximum cooling we can be able to get, that is a very important parameter which is going to be considered. And non-toxicity, it should not be hazardous to the health or environment, because all the eating substances are going to be preserved. So the preservatives may get toxic finally if there is any leakage. So it should be non-toxic. And desirable saturation temperature. So the saturation temperature should be desirable. And chemical stability, that is non-flammable, non-explosive. These are the very very important parameter: non-flammable and non-explosive. And we should be able to detect its leak. If there is any chance of leakage, we should be able to get to its or should be able to leak its detection. So of course, very economic point of view, it should be low cost and readily available, and access to everyone. So that is also, its availability is also very very important parameter. So this is are the few are the properties which is going to be considered as a desirable properties for any refrigerants we use it. So we'll just quickly go through a brief note on that, and then we'll just go to the air conditioning system. So friends, I think is all already being discussed now. So just give me a second. So properties of the refrigerant also given in the notes that I have shared with you already. That is thermodynamic property: low boiling point, low freezing point, and high critical temperature. I missed this high critical temperature. It's a point at which the change of phase from liquid to vapor and vapor to liquid which happens. So this also should be high. And also physical properties, as I was mentioning: low viscosity, specific volume, and of course thermal conductivity, and high electric insulation is also very important. And the chemical properties: non-toxic, non-flammable, non-corrosive, good chemical stability, all that. And other in terms of economical point of view, its availability, low cost, easy of handling is also very important. And these are the few types of refrigerants we use it. That is ammonia. It is one of the oldest and widely used refrigerants, because it has a, the normal boiling point is 33 degrees Celsius. Can you just see it here? So at 33 degrees Celsius, it starts boiling. I mean to say, the change of phase is going to be taking place at 33 degrees Celsius. So that is very, very important. And also cost and its availability is also very moderate. And but of course, with respect to its chemical property, it is very toxic and explosive. So it should be provided, if ammonia is going to be used, then it should be provided with a very strong system to avoid any leakage, because it's very highly toxic and explosive in nature. One more is sulfur dioxide, that is a non-flammable, non-corrosive, and absorbs a lot of heat in evaporation. Its boiling temperature is 10 degrees Celsius. So that is also good in terms of boiling point. And normally we use sulfur dioxide. Earlier we were using, nowadays we go for, more or less we go for freon or ammonia. So it's a carbon dioxide also can be used, but its temperature of boiling point is 77 degrees Celsius. That is the reason we normally don't prefer this, except if the refrigeration system is going to be operated at higher temperature, then we can prefer this carbon dioxide. So also freon, freon 12, that is R12 is the refrigerant it indicates. So freon is it is going to be designated as R12 with a chemical formula. So it's again its boiling temperature is 29 degree, and it's very suitable one. And even with different composition of chemicals, that is freon 22 also going to be used. Mm, its boiling temperature is 40 degree. So moderated hydrofluorocarbon also very popular nowadays. It's possessed health and safety properties to be used as an alternative to R12 and R22. So this is also being started using it, and its boiling temperature is maybe around 15 degrees Celsius. So this definition part of it, I think we have discussed coefficient of performance, relative COP, all that we have seen, and this is the parts of the refrigeration: evaporator, condenser, compressor, and only the four devices, and it is being given. So also we have discussed the vapor compression refrigeration system. This is a layout of the vapor compression system or the cycle. Simply also we have discussed the vapor absorption refrigeration system that already we discussed. Uh, so now if you look at the difference between vapor compression and vapor absorption system, it is that in the vapor compression we use compressor. Here we replace that compressor with the observer and heating mechanism, that is generator, right? So here we use freon 12 as the refrigerant, but here we use ammonia is going to be used for higher capacity. So it works on basically on the mechanical energy, that is by rotation of the, or by driving the compressor. So completely the vapor compression, which works on mechanical design, that is by operating the compressor. But here it is completely entirely on heat energy we use it, based on the Faraday experiment that we have seen yesterday. Uh, also but here we don't use a pump in the case of vapor compression, but we use pump as a very important device to circulate the refrigerant. So pump is also going to be used, but here because of the presence of compressor, noise is going to be you might have seen that a small a certain kind of noise we able to get it in the background, that is because of the presence of the compressor. But here almost it is going to be zero in case of observer vapor absorption system, that is in the absence of compressor. So as I was even mentioned earlier, it's the maximum capacity is 1,000 tons, but can be even designed to above 1,000 tons for vapor absorption. The chance of refrigerant leakage are more in case of compression system, but here almost all it is leakage, because there is no leakage because we use heating as a method. So here maintenance is going to be high because of the presence of compressor, and maintenance is low because there is no complex design, or complex components are using are less. Also, we use domestic or commercial industrial applications, but here you use it for storage and all that. So now we'll move on to air conditioning system. Before we just discuss air conditioning system, we know that air conditioning system also operates on the same parameter or the same basis, but Before we just start going it, just we'll discuss a preamble for it. So we normally we know that we use what is it? We use normally fan and cooler, air cooler, and all that. We use it, and also similarly sometimes we go use air conditioning system. So normally what happens in the fan? The fan, the room, it is going to be confident with the air particles. It is going to be forcefully, it is going to be the velocity of the air which is going to be circulated, or the air which is going to be circulated in the room, without without controlling or monitoring the air. Just it simply increase the velocity, so that the wind can be blow at higher speed. The wind can be blow at higher speed. So that is what exactly the fan which does. So similarly, the air cooler, which is going to be used without again moderating or conditioning the air in the room. What it does is simply the water particles are going to be the water which is going to be stored, and it is going to be sprinkled around the fan, so that the air particles which is moving within the room uh, also carries some water particles in it, so that so simply the water is going to be sprinkled against the fan, so that the air which is moving across at higher speed than the normal one, which carries a certain amount of water, so that we feel good. Uh, but without, again, in the air cooler, we are not moderating or we are not controlling the conditions of the air. But such a type of air cooler or fan which may not work in a places like, for example, if you take Delhi or any north region, if you take, where these devices may not effectively work, because the humidity is going to be more. Sometimes the humidity is going to be less. So for example, the relative humidity which is going to be more than 60, then it has to be reduced. If it is lower, then we have to add the water molecules with air particles, so that its relative humidity is going to be maintained appropriately. So at the same time, in Karnataka itself, if you go to Gulbarga, Raichur, it may very be going to be tough using these devices. At the same time, the air conditioning, as per our requirement, we can be able to control the conditions of the condition of the air, or the property of the air. For example, irrespective of the season, whether it is a winter, whether it is a summer, or whether it's a irrespective of this season, we can be able to moderate its, or we can be able to control the air properties. For example, in summer we may not we may require relative cold, or in rainy season, or in cold season, we may raise the temperature above the ambient condition. So as per our requirement, to make us comfort, we can be able to control the property of the air, and the same can be controlled and maintained throughout throughout its usage, and monitor the air which is going to be surrounded. That can happen with the help of air conditioning system. So air conditioning, what will it does is, so for example, if you it can be used in different way. It can be used, for example, we can control its air by increasing the temperature or decreasing the temperature without in just in a remote. The same can be used with for irrespective of the seasons, irrespective of the place. The place is also going to be very very important. For example, I have taken two examples, that is Delhi, and if you look at the Raichur or Gulbarga or whatever, or Ballari, and it is different from Bangalore. So it is also depends on the surrounding air, or the condition of the surrounding air. Based on that, based on the requirement, we can be able to moderate. So that is what exactly we can do in air conditioning system. So how normally we do is, for example, in summer, what will happen? The water particles which are going to be associated with air, which is going to be less. So in that case, the water particles are going to be added to the air particles in that particular season, and relative humidity going to be increased and moderate at particular required desired, sorry, for example, 60% is going to be normally 60% we use it as the excuse me, 60% relative humidity we normally maintain, so that it will brought up to the 60% relative humidity, and same thing it is going to be circulated and maintained throughout its operation. So that is what we does in summer. For example, in case of winter, we may require high temperature. So in order to require high temperature, normally what we does, so water particles surrounded in the air is going to be high. In that case, what we'll do, we remove the water particles from the air, and then we supply that to the room. So that is what we does in air conditioning system. So any air conditioning system or layout of any air conditioning system, if you look at, so normally uh, this is the room, the bottom portions, it is going to be covered in the room, and from the as you can see here, partition of the wall. So other than that, that is going to be outdoor. So normally we keep condenser outside. The condenser is provided with the fan, and that fan is going to be taken a that is going to be we normally keep it outside the room, and this is going to be a small passage we are going to provide to circulate the conditioned air to the room. Will create some passes, and normally evaporator is going to be placed inside the room. This is the evaporator. So again, in evaporator, so we will just quickly we'll go through the different components we use it. So this is going to be evaporator. This evaporator we normally keep it inside the room, and of course compressor. And this compressor, it is going to be driven by electric motor by supplying a power. And also we use it condenser. This condenser normally we keep it, you can notice outside. So this is the condenser, and this condenser is in different condenser in the sense it's a heat exchanger. So it exchange the heat from one to other with the help of either by means of fan, or by means of fans in the sense circulating air, or by means of water. Anything is fine. So uh, uh, also the same you can what you can notice here is we use only one motor throughout its device. We use only one motor. That one motor which drives the fan, which is used for condenser, and also the blower to suck the air from the room. So that is blower, and also the same motor which is going to be coupled to the compressor. So the one motor itself, which is supplying the electric or rotation of the shaft, it is going to be done for both fan, blower, and compressor. Same, all the three are coupled to the same motor, one motor, and expansion valve. So these are the common devices which use in any air conditioning system. So what exactly it does? So before just entering the air, which is going to be keep it cool, that air which is going to be sucked by the evaporator through a filter, or through a filter, any air contaminants which is going to be present, which can be restricted here, we're using the filter, or damper sometimes we use it. So through the its damper or filter, the air which is going to be circulated over the evaporator. So with this what will happen, with this what will happen, because of the air which is being circulated in the evaporator, it gets heated. So due to which what will happen, due to which the air which is going to be starts evaporating. So this, will it is at very low temperature and pressure. This is going to be circulated to compressor. Due to compression, what will happen, it increases the both pressure, already sorry, both pressure and temperature. So this both high temperature and pressure, it is going to be circulated in the condenser, will condense, or it is going to exchange the heat from circulating air to the, here what will happen, the air which is going to be circulated, that will cold, that is going to be cold, and it liberates the heat and pass it to the surrounding air. So this is what the heat exchange which is going to happen in case of condenser. So the air which is going to be supposed to be circulated, which liberates the heat and pass it to the surrounding air, or surrounding heat exchanger fluid. So after that it will come to the so again, if you look at, it is going to be still high pressure, and but it is low temperature. Because low temperature, because already it loses its heat. The air which is passing over this tube, it loses its heat, and because it is passing it to the other circulating media. So that is why it is low temperature, but the same high pressure which is being maintained. So before we send it to here, we may not require that high pressure. We only bother about the temperature. We don't carry the pressure is going to be not be going to be the important factor here. So the pressure is going to be minimized in this case. So with that can be achieved with the help of expansion valve. It is going to be expanded, and finally the same low temperature is going to be maintained, and only the pressure which is going to be altered in the expansion valve. So that's why low pressure, low temperature liquid which is going to be passed on to the evaporator section, it circulates the air. The air which is going to be monitored, so that air which is going to be circulated in the room. So this is what happens. So in between, normally we use it, maybe the layout or the working operation which is going to be different for each cases, whether it is water going to be added or water going to be removed. So these are the two important process which are involved. Either we add water or we remove water. So that I will just come up with the next class, and then we'll further discuss about its application and different types of one or two types of air conditioning system we are supposed to discuss and all that. So with this, we will close it today. Probably in my next class, I think we can close this model. So thanks for joining today. We'll close this.